Hi, I'm Bob, and welcome to Between the Sheets, where we look at Microsoft Excel and related technologies. Did you ever have to make regular payments to someone? Yeah, what a question, right? Or better yet, maybe you've received regular payments, like maybe an annuity or you won the lottery. Well, you might want to know what's the present value of all the payments once they're completed. Present value is the value today of all the payments you'll make or receive in the future. Excel has two functions to calculate that. One is the present value function, and the other is the net present value function, which allows uneven cash flows and subtracts the initial cost of the investment. If you want to skip ahead directly to learn about net present value, go right ahead. So let's take a look and see how it works. In this example, we're receiving or paying $200 a month for 10 years. At 3% yearly interest, what is today's value of all those 120 payments? For that, we'll use the PV function, and that has four required arguments. We say equals PV. The first argument is what is the interest rate? We saw what that is. How many periods? What the payment amount is, right? In this case, it's $200. And what is the future value. There's a few optional arguments you'll never use, so I'll ignore them. So let's go do it. I'm going to say equals PV, open the parenthesis. So the rate we see is 3%, but that's 3% per year, and we're talking about monthly payments, so I have to take that yearly interest and divide it by 12, comma, number of periods. Well, it's 10 years, so I have to take that and multiply it by 12, so we get the 120 months, comma, the payment amount, well, that's straightforward, that's $200, comma, and the future value we see is 0, and that's because once the payments are stopped, they're done. There's no more value after that. So I'm going to hit enter, and I see it's a little more than $20,000, almost $21,000. Now, you see this is a negative number because Excel figures you're making the payments, so the negative means it's cash flying out of your pocket. But if you're the lucky one getting the payments, this should be a positive number. Now, the cleanest way to do that is to change the payment amount in the formula itself to make that a negative number. So you see that B6, I'm going to make that a minus B6, right? Because B6 is the monthly payment. When I enter that, now we have a positive number. Now you know that if you get $200 a month for 10 years, it's worth almost $21,000 at 3% interest. Important to know if you're selling your lottery winnings. Now let's look at the net present value function. In the NPV tab, you can see we have uneven cash flows. It also lets us factor in the initial cost. And you see we have two options to evaluate. You don't have to do this, but I think it might get the point across. So the second one you see produces larger cash flows here, but you see it also costs more. So we could figure out which of these options is better financially. So let's look at the syntax of the net present value function. So that factors in the initial cost, and you saw we had uneven cash flows. So the syntax is actually even a little easier. It's equals NPV, and then we plug in the interest rate, then what all the cash flows are, right? Cash flow 1, number 2, number 3, however many you have, and then we subtract the initial cost. So you saw on the sheet, the cost is a negative number, so we have to be sure to add it. Otherwise, we're going to be subtracting a negative, and that's going to turn into a positive number, and the result just won't make any sense. So let's do it. I'm going to say equals NPV, and so the rate is 3%. Now, we're dealing with yearly cash flows, so I'm not going to do anything to the rate. I'm just going to leave it as yearly, comma, now what are all the cash flows? And I'm going to leave that cost alone there. I'm going to just select here are all the yearly cash flows, close the parenthesis, and now I'm going to add, so I'm going to say plus that negative number, right? I got to make sure that I'm not subtracting the negative. I enter it, and I see that it's a little over 14,000. Let's evaluate the next one. So I'm going to say equals NPV, open the parenthesis again, it's that same 3% yearly, leave that alone, comma, here are all of the uneven cash flows, close the parenthesis, add that negative 75K, and enter that. So we can see that even though the second option produces bigger cash flows, the higher cost makes the net present value worth about $5,000 less. So maybe that second option isn't such a great idea. Excel has several tools in its arsenal to help you evaluate investments and costs. Present value and net present value give you some solid insight. And if you do win the lottery, hey, remember who sent you. So be sure to check out my course, Excel 365 for Busy People. Until next time, my name is Bob, and this has been Between the Sheets.